Hey, so welcome back to my channel. Today I'm picking up again where I left off last time, and that is doing some more vibe coding. Got a couple things going on here. Let's see what else I got here. Well, I'm still working on the aerial garbage detection rework, redoing the site, and taking all the lessons I learned from the last version and reworking everything so that I'm taking full advantage of everything I've learned, which includes things like how to label images. It includes things like how to train a model, lessons about how I could have done things better, how I would have liked things to be more efficient, more streamlined in terms of the operations. And just doing a lot of things here. So let's see, I wanted to do a backend file browser. So I'm right in the middle of a little session here. I will cut over to that. So what I'm doing right now is I actually have a few Claude sessions open. I had one that's going through and adding a delete endpoint. So I guess we can go ahead and test that first. I wanted to be able to delete data points in my data set. So say I'm here in my annotations and I go and I say I want to show all the pending ones that I haven't approved for training yet. And say I find this one, which is from a data set I purchased from another state. I don't like this particular one because it has too much, too many of the things I don't care about in it. So it's a little bit too noisy. And so I just had, and I guess you can't see it here because I'm covering it, but I just had Claude add this delete data point here so I can delete this actual data point. Okay, so now that's going to be gone from my data set, which is nice. I've also added over the past day, or since the last time I posted a video, all these categories. So now I can actually categorize things by what type they are. Now, I don't know if I'm going to actually use all this, but the categories are essentially mostly pile size, and then there are some specialty categories for things like mattresses and tires. So you can see I have it automatically choose the size of the pile. The reason I did that is because I found that there are things where there's like a lone box out here, and yes, I want to capture that because it is garbage on the street, but I don't necessarily want to report that every time. Or even little things like this. These are like little cups and boxes, and like, yes, I want to capture those there. I don't necessarily want to report them. So having them sort of separated out as a different type of garbage can be useful. Now my model can also combine all these. I can have a model that uses all these together, or I can have it detect these as different classes. And I could also filter them out and only train it on, a model on certain classes. And so I'll show you that. So I thought through all this. You can basically go in here and you can click any one of these and you can change the class. This is, what is this? This is a piece of cardboard. Looks like this is a small piece of garbage. This is a pile of garbage, or maybe even two piles of garbage. I think one pile is good enough. And these are just kind of random little bits of garbage. So I can now add those to my data set. And now if I go into like the training view, I can't show you this now because I'm in the middle of a training run. Actually, maybe I'll show it to you once this training run's done. But we'll just jump in and look at where the training run has gotten to now. So the training run page now shows you the progress. It shows you the different labels that you added to this one. I applied a filter and I am training it on all data points, even ones that haven't been approved by me yet, because that's the original data set that I was using. It had all of these annotations in it. I downloaded that data set, took the whole site offline, and I imported those data points from my training data into this system. And now you can see I have 22,145 garbage pile annotations. And now I'm going through and I'm just really thoroughly checking every single one of these annotations. one by one. So I have a status that I can add to each data point, each image, which can include multiple annotations, notating whether that image has been approved by me yet. And so each time I iterate through it, what I'll do is I just use that as kind of like a bookmark, a progress bookmark, to let me know how many I've done. And then if I finish, then I can clear them all and start fresh the next time I go over them. So anyways, I'm using all for now just to see what happens. It looks like it's going pretty well from what I've seen. And then I can go in here and I can look at like prior runs. I've already shown you this where they're not doing that well from prior runs, but that's because there's very limited data in this one. So it's sparse and limited data, so it's hard to learn. Now that I've put in the whole data set, it's actually learning quite well. We can go in and look at some examples. So it's giving me like periodically. I gotta turn off that auto scroll thing. Periodically, it's giving me a sample of what it detects. And so, for instance, you can see here, the red box is the current model that I'm training and what it's doing. The green box is the ground truth that I provided it. I think the red is actually better than the ground truth. I should probably adjust this ground truth because this bounding box is way too large for this pile here. This one's good. This one looks really good. It missed this one here, which I can't blame it. That's actually kind of a tricky one because of the barriers. Here, there's one that I should have labeled. This looks like some data that was outside of my training set for sure because it hasn't been munged yet. So yeah, let's see. Here's another one where it detected this pile of garbage. This one, yeah. So it looks like it's kind of learning, and it's only on epic 40 right now. It should go to like 180, 150 epics. Yeah, so this is the training view. You can look at it in raw mode and then set like auto scroll on. It'll stay at the bottom and keep track of like what's happening. But that's annoying. And once I get in there, I can't get out because it keeps scrolling to the bottom. So I'll turn that off. And then once you finish a model training, let's go find like one of the models that was a little bit better. This one performed pretty well. I think this one performed better. If you go in and view the full results, you can actually run inference on those results. You can look at the training plots that YOLO produces. You can run the inference on example photos. So you can see here, this is the ground truth. And so if we get rid of the ground truth, you can see here's what it predicted with a 50%. If I go down to 25%, it will probably predict more things. And it's made it's done a good job actually. It made a mistake here with this poll, but it got this garbage, that garbage, that garbage, that garbage, that garbage. So it's detected this model, which is trained on a very small portion of my data set, but a good quality one. Seems to be doing pretty good. We can see how it does at night here. Here's a night photo. It hasn't detected anything. That's not surprising. Here, it hasn't detected anything major. I think this is a relatively clean street. And then over here, it's detected some garbage. So you can see like that one. So you can actually click here and you can zoom in and see like the garbage pile it detected. It missed this. It got this, which is wrong. But that'll get better with a larger data set. And it got this, which is wrong, which is like a fire hydrant. Those things look like garbage, but they aren't garbage. So, I mean, fortunately, though, this percentage is really low. So the confidence is low on these. And if I were just to set the confidence to like 40%, it would have one false positive there. But this will get better with a larger data set. And you can already see it if you go back to my current training, which is using a much larger data set. You can see the percentages look a lot better. Like this one's already at 77%. And so I think we're going to be good. And then as I refine the data set more and more, I'm going to get a better and better model. Yeah. So I've done a bunch of training runs. A lot of them failed. Some of them completed. This is just as I'm developing the application. And then I have my annotation tool here where I can go through and say, let's look at all the pending ones. I can export the existing data set to YOLO. I have this extra little list view that I created where if I have dual screen monitor, I can do the selection over here and then do the annotation over there. And then it's a little bit janky there, but it's fine. So then, yeah, it's really cool. And the way I do this, as I showed you, is I just work over here in this other, in some Claude windows. And so Claude is doing some tasks for me now in the background. Here it's asking me, I wanted to create the inference pipeline now. So I have some trained models and I'm going to use Claude to create a way for me to open a folder of images on my computer drive and have it scan those images, process them through a trained model that I select, and then map those images onto the street. So what that looks like is here, if we go back to the calibrate images, you'll see that we can select an image and it gets mapped onto the street, right? Well, each pixel in here is mapped to a location. It's projected to a location in latitude, longitude, at the ground elevation where this photo is taken. And so, for instance, there's garbage right here. I can get the precise location of that little bit of garbage in the world and actually know the latitude, longitude of that piece of garbage, which is what the next step will do. The next step will actually take detected bounding boxes of garbage and map them into the latitude longitude space in the real world. So that's going to be cool. And at that point, the next thing to do is to reintegrate with SF311 and with some other 311 systems to report these things through the system. So I have a lot of great ideas for that, because what I've done in the past is I've done a lot of learning, a lot of getting my hands dirty with these detections and going through and like checking all of them by hand. So I'm very familiar with what might work, and I have a lot of great ideas. Using a VLM is one of the ideas. I've used like intern VLM in the past, but VLMs have gotten even better. And I can use a VLM to do some discrimination on the garbage piles to figure out, like, is this something I want to report or not? So I can ask the VLM questions like, does this look like enough garbage to fit in a truck? I can even fine tune it on questions like that. So I can take a VLM and I can grab a number of garbage piles and like teach it to estimate volume, teach it to estimate whether it will fit into a specific kind of truck. I can also teach it to describe the garbage pile and describe, like, is there furniture? Is there a mattress? Is there a loose debris? Is there bag debris? I can teach the VLM to give me precise location descriptions. Like, it's on the edge of the curb, behind the blue van. Things like that that really help the crews actually locate where the garbage is if they can't see it. So there's a lot of new things I want to do the great thing is Claude is there to help me do all this stuff. So Claude can help me to do this really quickly. Another instance of what I'm going to do is I have a couple of these NVIDIA Jetson little supercomputers. They have a GPU on board, an ARM processor, and they can run object detection and other AI models really efficiently. And I can export the models I'm training to run on here in a special format that this thing can run really well. And it uses all of its tensor cores to do that. And then I can take this in the field with me, take it in my car, plug it in, and when I'm done with a flight, just plug in the SD card, and then my application can automatically see that an SD card was inserted, look for images on it, and immediately start processing them, detecting garbage, and uploading the detections to my server. That's going to save a ton of time. So we'll take detection time from what it used to be, which was flight time plus about 30 minutes to an hour to finish like reporting all the detections. And so you're talking like an hour and 30 minutes, an hour, up to 2 hours just to finish reporting all this stuff. Whereas now, what I can do is I can fly after the first battery land, switch out the SD cards, plug the first SD card in, launch the drone back again with a fresh SD card. While the drone's flying, it can start reporting things or start finding them, sending them up to the cloud instance, to the server, and we can have reports like within the first half hour start flowing in, which is really cool. It makes it so I don't need as strong of an internet connection out in the field, because I'm not uploading all the images, and so I'm only uploading immediately the ones that actually have garbage in them. And I'm not going to necessarily upload the full image, which is like 16 megabytes per image, but just the part of the image that surrounds the garbage, which can be like kilobytes. Still pretty high resolution, but just not the full drone image. So there are a lot of inefficiencies that I'm solving this time around that are going to take this to the next level. I'll also be adding in route planning. So I'm going to create a dashboard or a view where whenever the user decides they want a route, they can take the detections for that day that have not been cleaned up, the ones that have been reported and not been cleaned up, and automatically create a route, which can then be sent out to people via SMS message or other methods. Just basically a link that opens up a little static page that has a route. And maybe even we can add like some GPS tracking in there for people who are using their iPhone or their phone to see where they are, and we can track where they've picked up. Maybe make some easy buttons to say I've picked that one up. Which we can maybe even have like an integration with your own one where we update it and say, hey, this one's been cleaned up, and then have the drone actually verify that on the next flight. So yeah, there's a lot of cool stuff we can do. It's fun just to apply my problem solving mindset to these things, and really with it takes some more experience probably before I decide exactly what I'm going to do, but I definitely like to have some of these in my pocket and ready to deploy if they're going to be helpful. So let's go back here and see where we left off. So we were looking here, and it's asking me, how do you want to find the images? Do you want to do a configurable path? Do you want to do a backend file browser, bring up a UI, or do you want to do a dedicated like upload through the browser? I want to do a backend file browser because I just want to like select the folder, and I want to keep them in a nice redundant storage space. And this is for what I'm working on now is the server side, which is mostly for testing. In the field, I'll be using the Jetson, like I said. These are DJI drone images. Okay. I want to navigate through images individually with their detections. Show all image footprints and detections overlay on map. Detection, show only geolocated detection points, markers, no image overlays. Okay, so I actually want to do something a little different. Let's do... Okay, so it's asking me, how do I want to display the results on the map? And you can't read it very well because of the background here, but let me just switch that up. Style, theme, we'll go to ethereal. Okay, that's better. All right, so it's saying, how do you want to display these images? I don't want to put them all at once on the map because it'll slow down the map a little bit. I mean, I think it's actually pretty good. Let me go try that real quick. So you can actually select all here, and I think it does a pretty good job of rasterizing them onto the map. So you can see here, it's actually put all the images, all these drone images over the map here. Oops, but it does get a little bit laggy when you put a bunch of like high resolution images over the map. But you can see here, it's like, oops, look at that. Yeah, maybe that's not the best idea to do that. But here we go. Let's just put them all there, and then we'll go to this one here. And what we could do is put them all like this and then have the bounding boxes kind of over there, which would be cool because it'd be nice to be able to visualize it. But now that I think about it, I think the better thing is to actually have it just put the detections only. Yeah. Because it's going to be nice just to see like where the garbage is. I can verify whether the images are properly calibrated in the calibration view. And then I can also have the detection points linked to the garbage image itself, or even load up the garbage image when I'm looking at a specific point. I want to look at something here because I think our training might be done. Let's see. No, the training's still going. All right, let's look at this. We have done 50. Okay, that auto scroll thing needs to go away. And now we can go look and see how our thing is doing. For instance, here we've detected that's a bad detection actually. Okay, that's but this one is correct. Okay, and then here, this is still good. It's got this one. Now it got this one, which is good. It learned that. Last time it didn't have that. It has this one. It has that one. It has that one. It's still learning. Here, that. Here's another one where it got this, and that. So that's good. It's good. It's learning. It's learning. And we'll see it get better and better, I think, this time because it's processing the full original data set. All right, so let's go back to training, and let's go back here. Navigation could be improved here a bit. Let's go back home, and let's go to calibrate images. Yeah, so I think what we're going to want to see is like when you zoom out, you see points. And when you click a point, if you go to a point, when you zoom into a certain aspect, a certain zoom level, it will show the pile overlaid on the map. And then I think Street View is actually a little bit more useful because of the zoom, how the zoom works. But yeah, so you can kind of go in and see where that is. And it'll be nice just to look on this map and see all the garbage piles overlaid. I'm going to work on getting a better map tiling, something. I might have to pay for something that lets me zoom a lot further. Or maybe even create my own from all the drone images. I don't know. I want something better than this, and I want something better than the satellite view here. So, yep. Okay, so it's asking me another question. Yeah, let's go ahead and do it. It just asked me, can we go? Can we do this? And I said yes. So one thing I like to do while I'm working is I will pull up a Git view and make sure that I'm like updating things and keeping it, keeping my Git history up to date. That way, I like to save checkpoints as I go. Whenever I'm doing a new feature, I want it to be starting with like a fresh checkpoint. That way I can do this. So now what I can do is actually, let's see here. Oops. Okay. So now I should be able to see the changes as they come in, and whatever's happening here. All right, so I've got this like backup folder of like that it contains a lot of data. I probably need to take that out of this repo because it's slowing things down when my IDE has to scan all those files. Some of those are like hundreds of megabytes of JSON. In fact, I'm going to do that right now. Okay, ls. Let's back up. Okay, move back up to my home directory for now. Okay, and we'll get out of there, and then we'll go here, full screen that thing. Hopefully this speeds things up a little bit. Whatever's doing this is like kind of worrisome because this computer is very powerful. Okay, so now you can see, oh, it's keeping the data set in here too. Okay, that's fine. I'm going to tell Git to ignore a couple things. Let's see here. Okay. Okay, we're gonna do Git. Okay, we're gonna do Git ignore, and we're gonna ignore dataders. Okay, so we're gonna ignore refined set. I don't even think we want to. We're going to ignore viz detection. In fact, I could probably delete these because they're irrelevant now. But for now, I'm just going to ignore them so I can think through that a little bit more thoroughly before I do delete them. Let's see. Yeah, that should be good. Oh. And then we want to ignore the star.pt and okay. When did I last touch that? Okay. Okay, that's much better. All right. So you can see like what it's changing here as it's working. That's kind of nice to do. That's what I like about having like a Git view open like this, where I can watch that it's changing things, what it's doing as it's working through things. This, I thought I told it to ignore VIT detection training, but okay. Yeah, okay. Okay. So yeah, here we go. All right, let's see. So it's still working. And this is the beauty of Claude. It's like it's like doing the development. It's doing all the grunt work for me. I can now sit back and think about what I want to do next. Like for instance, I had already been doing this delete endpoint with like the being able to delete a data point. While that was running, I thought of the idea that I want to go ahead and start working on the inference view. And I set this thing to go to work. And then I started making a video with you. And now while the video is running, I've come back and seen that it needs a little input, and I gave it the input. And now it seems to be done. Okay, so did it create an inference view already? That's going to be kind of crazy if it did. Let's see here. Let's see, that's full screen. Okay, so we can close that and close that. And let's go back home. And we've got like our geo inference view. So I can pick which model I want. Let's go back and pick this one here. And then I haven't selected a directory, so we'll go and select, where are these? App training data. Okay, files. So we're going to go here and go to home, repos, bits. Where is this app? Backend data. Is that like /app? Backend. Okay, front end. No. I don't know where it put that stuff, but let's just find it. I'm gonna have to ask it. Where is that located? Let's just. Where can I find the? Oh, is it like really, literally like the root path? Let's see here. App. Okay. The app training data. I wonder if that's just like inside of my container somewhere. Let's see. Okay, so let's see. Run media 59. Oh yeah, Brian. Okay, data. Okay, here it is. Okay, so I want to put some files in here to run inference on. So we'll grab some from run. Oh yeah, there's just like here. YOLO. We may use something from like the validation data set here. Okay. And we're gonna, okay, so we'll just grab that. Okay, make dir testing. Copy YOLO images. ZZ star. Okay, so now we have some images in that testing bin. we can close this down and we should be able to refresh this and see there's a testing bin. Okay. Select 4 images and run inference. Oh, failed to run inference. Why? What did we get? It's not surprising. Kind of stuff happens sometimes. All right. So we're just going to go tell Claude, you forgot something. That easy. And it figures it out. And if it doesn't, then we help it. But it usually does. Okay. So that, yeah, so we did that. We've got this map view. Let's see what else we might want to do here. So now it has a map view. It's going to be able to hopefully map these images onto here with the detections and bounding boxes and allow us to see where this garbage actually exists, if it finds any. All right, let's go back. So we have, let's see, this calibration stuff here. I want to clean that up a little bit. Calibrate and scan input. Process all images, scan input directory. Process all images, scan input directory, and calibrate all should be 1 unit and live under a button menu. So maybe it'll create like a little menu where I have like a drop down and I can select like which one of those I want. That way I don't have like all these buttons cluttering, which kind of work on the same part of the app. Looks like it fixed the inference code, so we're going to go check that out. So we're going to go to geo inference, select 4 images, run it with this model here. Okay, it's running, and it found 7 large piles. Where did it find them? Somewhere in here. Where did it actually, let's see, street satellite. Okay, now how do I see the images on here? Oops. Well, where did it put them? Seven total detections. 7 geolocated. Ah, there they are. Look. Boom. It totally mapped them onto the corners right there. So I just did that. Oh my God, it's so great. I mean, I have a lot of this stuff already figured out, like how to map stuff onto the world, but I didn't have it all like pieced together. So now what I'd like to be able to do is click one of these, and I want it to, when I get to the highest zoom level, I want it to show me the image for that zoom level. Okay. When I zoom into the map and there are detections at the highest zoom level, render the image, the entire drone image from which the detections came onto the map. And so hopefully it'll know to go use the calibration, the correct calibration. To do that, here, All right. Okay, let's go check out this drop down and see if it did a good job on that. In fact, we'll just open that up in a different tab. Yeah, look at that. That's exactly what I wanted. It did exactly what I wanted. Oh, God, that's so good. Okay. Okay. Yeah, so this is the window where I was getting it to create a YOLO optimized mini application within this app so that I can install this onto this this guy, and it will all work automatically. And I'm going to have my application export a special format of the YOLO V8 model that will run on there super efficiently. And I'm still working out exactly how I want that to work. If I there's a point where a city might want to fly their own drones. And at that point, I want to make sure that they don't have to have like a bunch of extra equipment and that they can operate really easily. It would be nice if I could give them one of these, but I don't want them to have to carry one of these around in the field and keep a battery and all that stuff. That could be too much extra cognitive load. So I've got to figure out what they have handy, if they have a laptop or whatever, and what I can do to utilize that hardware in a way that saves us from having to upload all the images, which takes too much time. I don't want them to wait. So there's a lot of little things like that I want to figure out. While I'm doing the drone flights myself, I can easily sort all that out. It's going to take a little bit of like talking to people that are flying the drones that other than me to see what they're comfortable with. Let's see if it's done anything yet. Look at that. It's there. It's so cool. I'm really curious to see what these garbage piles are in reality. Okay, so now we did it. We have it. We tried it. We can refresh here and then zoom in to our location. And I think we lost our inferences, but we'll grab a new one. So we'll select those. We'll grab that nice model. We'll run inference. And there we go. It's now, it's placed it on there, but it hasn't done it properly. So it did. This is the kind of thing that can happen. So we have to, what I can do is actually give it a photo of this and be like, hey, make sure you do this right. The image should be mapped onto, or projected onto the map, projected onto the map surface using the same technique we used in calibrate. Okay. So now it's going to go about doing that. And we can go back here. Check out our training again, see where we're at. We're at Epic 60 now. So which means we have new results to look at. All right, let's see if it learned anything new. So sometimes it takes a little step backwards. So you can see that like last time we actually detected this. This time it did not. It's going through little local minima and maxima and figuring out things, but it hasn't figured them all out yet. And it could be that we need to work on our training data set a little bit more for YOLO V8 versus the architecture I was using before, which I think was like, it was different. It was not a transformer-based architecture. It was a CNN, convolutional neural network. Okay. Oh, did it already fix it? Look at that. I think it may have. It does look like it did fix it. Okay, so we got our detections, which were here and here. And then we got another set, which were over here. Yeah, there and there and there. Very interesting. Now I want it to actually. Well, these are the actual images, and so where's the garbage that it detected? Because I am not seeing it. It seems like the map, this maybe flipped or something. Because I see some garbage there. And if it was rotated, this would be about there. These would be on that sidewalk, which would make more sense, which would mean something over here. Right? No, this would be there. This would be here. Yeah, I don't know. Something's not quite right about that. We'll figure it out. This one, if it was flipped, we'd get that pile somewhere over here. It may still be working. We'll go check. Okay. Testing. Select 4 images. Let's do this one. Oh, that one had a lot more detections. Okay. Yeah, that's not quite right. Okay. Let's have it rasterize the, we're going to have it raster, draw the bounding boxes on the image before mapping, before projecting it onto map. That way we have the actual bounding boxes printed on the image, and that will tell us where these are supposed to line up. Then we can check the map rotation to see if it's properly rotating things, and then we'll be good. Because it needs to rotate not only the map, but it needs to rotate these actual little detections as well. Okay. Let's grab some more images too. Let's get AA. Okay, we'll do like AA star to testing. Run media. Oh no, we want to go to run media. Okay, and we'll also do AA. Okay, and then we'll go back here and we'll do testing again. We can refresh so we get more up. looking for the images that I copied over. They didn't appear to be there. So we're going to oh, that's why. Copy. Okay, so now up, testing, select 11 images. Now we'll grab this one. We'll run inference on that. And zoom just way out. Oh, because one of those probably ended up in another state for my data set. Okay, these are kind of randomly thrown around. If we zoom in, do we get that? No, it's not mapped properly. But did we draw the bounding boxes on there? I don't see them. Not yet. Okay, we have ones over here we did. Okay. The views here aren't great. That's kind of a bug. Right. Satellite. Yeah, that's totally not mapped properly. But we'll fix it. Detections query parameter. So you draw. Okay. Will now be drawn on the images before they're projected on the map. Here's what I changed. Okay. Let's see if we can redo that. So let's reload this page. Let's grab testing, select those. We'll do this one. Where's my other thing? Did I do something in another state or something? Oh yeah, here in Dallas. I have one that I did some test runs in Dallas. And here you can see those. And there's the bounding box. So yeah, the map is not rotated properly. There's a little bounding box right there for garbage pile and a garbage pile. And so if we go to these over here, so let's go back to San Francisco. Okay, let's go to this one. Oops. So where are the bounding boxes here? That map is too small. I mean, the image is too small to zoom into on this map. Okay, but that one's not. Okay, so let's see where the bounding box is here. I wish I would make the... Oh, there's one there. Okay, so yeah, this is flipped in a weird way. It's not properly flipped. But this could have to do with these images being old for an old drone, and where I didn't have like my DJI Mini, where I didn't have like the GPS properly set up, or I'm not mapping that. So if I grab an image from like my newer drone, maybe it'll map properly. We'll see. Because this would have to be like flipped. Oh man. All right, it's getting late. I should probably go to bed. Anyways, that's it for tonight, and I just wanted to share like my latest progress and updates on what I'm working on and what's exciting about Claude and what it can do. And I will see you next time.